Let's look at now cube related questions. One is a big word problem, and I've told you word problems are not always that bad. So let's pay attention to this question. Two boys are playing on a ground. Both the boys are less than 10 years old. So they are single digit numbers. Age of the younger boy is equal to the cube root of the product of the age of the two boys. That means if the age of the younger boy is x, the product of the two boys has to be x cube, which means the brother is x square. And they both are single digit numbers, so we just have two possibilities. Younger son is 2 years old, elder one is 4, so then you get 8, and 2 is the cube root of 8. Or the second possibility, younger son is 3, elder son is 9, and you have 27. Again, 3 is the cube root of 27. So we have these two possibilities only. Now let's proceed further. If we place the digit representing the age of the younger boy to the left of the digit representing the age of the elder, we get the father. So the father is either 24 or 39. Similarly, if you do the reverse, so you put 4 first and 2 later, or 9 first and 3 later, and you divide by 2. Now 93 cannot even be divisible by 2. You will get something in fractions. Whereas the mother of the younger boy is younger than his father by just 3 years, which is an integer. So 3 and 9 are out. You have only one possibility, 2 and 4. And the age of the younger boy is option 3, which is 2 years old only. So you see, right, that you read problems slowly, you read and solve. Even word problems are not that difficult. Compared to question 1, question 3 is far more difficult. Which of the following numbers cannot be a perfect cube? So, one way of doing this, if you don't know too much, right, is to find the cube root, assuming it's a perfect cube, find the cube root and then square it up to find the cube of that cube root. So, for example, if you're checking for the first option, 175616, right, as we have discussed, since this ends in 6, the unit digit of your cube has to be 6. And now we'll forget the last three digits. 175 lies between 5 cube and 6 cube. So this has to be the smaller one, 5. So then I will find out 56 cube and see whether that is equal to 175616 or not. That's one way of looking at it. Clearly it is, so the first one is a perfect cube. But this is really tedious doing this for all options. So obviously if it's a question in the CAT, there must be something else that we need to check for. We cannot check for the unit digit because a cube can end in any digit. It can end in 3, it can end in 6, it can end in 9. What else can we check? Let's see, you have 3 odd numbers and 1 even number. Let's look at this even number. This even number, if it is a perfect cube, has to be divisible by 8. If you see the last 3 digits, 876 is divisible by 4 but not by 8. So this cannot be a perfect cube. So your answer is option 3. So it wasn't so bad. We have a brute force method and we have an elegant method. I hope you enjoyed today's session on cubes. I'll go and read Red Square by Martin Cruz Smith, and you can have a good day.